Cloud and Enterprise Division, responsible for the architecture of the data center to support higher availability, greater efficiency, and lower cost. He is the inventor of over 10 patents covering hyperscale computing, infrastructure operations, user experience, and distributed systems. Ladies and gentlemen, Mr. Keane.
Good morning. Thank you very much for hosting Microsoft here today. This is, in fact, a culmination of what's been going on for over 20 years for Microsoft, so we're delighted to be again here this year supporting the Air Force. As you've just seen from that video, at Microsoft, we're making a massive investment in cloud. And what this investment is ultimately about is supporting an intelligent mission. And that's what I'm going to talk to you about today. We talk a lot about cloud, but sometimes it's a little bit nebulous and a little bit hard to explain. At Microsoft, we are literally investing billions of dollars to make our cloud a hyperscale platform for growth to enable your mission. We have millions of servers sitting in hundreds of data centers around the world that are building this hyperscale and elastic infrastructure to ultimately better support mission. And this is connected together with one of the largest fiber networks on Earth to ultimately enable you to do anything. And what hyperscale means, and it's a word you'll hear a lot when we talk about cloud, is what you use is what you pay for. You want to use one virtual machine for 1 hour? Great. That's all you pay for. That's all you use. You want to use 10,000 virtual machines for a week? That's all you pay for. That's all you use. This image is a great image of, I think, what we're up to at Microsoft. This is a next generation of data center that we're building in Iowa. Each of these 4 buildings is large enough to accommodate 2 737 aircraft inside of them. It's a highly available infrastructure. It's designed to withstand failure with redundant paths of power, with multiple paths of ingress and egress for network. In fact, one of these entire structures can fail and an application will continue to run at the highest levels of availability. And at Microsoft, we're building one of these a month. And what's driving this growth is not startups, it's not cloud-first organizations, it's enterprises. It's industry like manufacturing, like retail, like defense, government, financial services. This image here is our data center footprint in Dublin. And in Dublin, we're getting to a size of growth where, in fact, in the next 2 years, we're worried about running out the Irish electricity grid out of power. And we're exploring alternate technologies like natural gas. And what's fueling our growth in Europe, in the United States, and in Asia A good example is what's going on with financial services. The largest banks in the world are called the G-SIFI banks, globally systemic important financial institutions, or put simply, banks that are too big to fail. 80% of those banks are Microsoft Azure customers. And they're not just putting in little workloads, they're not just trying it out, they're running core mission workloads, core banking workloads in our cloud. So it's a great example of where we've been able to work with organizations that have the most demanding regulatory requirements, compliance requirements, security compliance, audit requirements, and be able to partner together and break through those requirements to allow them to adopt cloud at massive scale and ultimately provide a better experience for their customers, to run a better bank, and to actually feel better about their security and compliance. One of the other secrets that we have is at Microsoft, we have one of the biggest networks on Earth. And it's an artifact of what we're building with cloud. We're literally laying subsea fiber cable. We have submarines that are building our network. We have buried dark fiber around the United States and Europe. We have a bigger network than most telcos. We have a bigger network, in fact, than many of the large telcos combined. So as you think about the CONUS mission that you all have, you think about the OCONUS mission that you have, you think about the dynamics of the battlefield, you think about the dynamics of just simply global interaction, you can literally be leveraging this infrastructure to have a highly connected experience anywhere on Earth. And this is not just highly connected, it's highly available as well. So it's literally dependent upon my stock price, my commitment to Wall Street, that this is a highly available infrastructure. The future of our company depends on this being an incredible infrastructure. Now, we talked about banks, we talked about industry that's adopting cloud. There's also new technology paradigms, like the Internet of Things. When we look at Rolls-Royce, Rolls-Royce engines power over 50,000 aircraft flights a month. And Rolls-Royce is not new to proactive maintenance, to monitoring the performance of their engines, to understanding different data points. What Rolls-Royce have done recently is they're now using the Azure technology, they're using our Internet of Things platform to collect thousands of sensors off each of these engines. It then allows them to move from proactive maintenance to predictive maintenance. They can then determine, based on artificial intelligence algorithms, machine learning, when an engine is potentially going to fail ahead of time and take that engine out of service. They can also use this to, for example, do fuel modeling and efficiency. So Rolls-Royce is doing things with IoT that are saving their customers money, that are allowing them to build better engines, and then ultimately transforming their mission and their customers' missions. And we're now at a point with IoT where we're connecting and collecting over 1 trillion data points a month into our Azure platform. And that's just the beginning. In fact, it's got so large we've stopped counting because the number is so long and so hard to read. Another really interesting thing that's happening right now in the technology space that has a real impact on mission is the innovation in hardware. For the first time really ever, the innovation of hardware and the innovation of software are aligned together. It would have perhaps been ludicrous for me to put up a slide and talk about a GPU chip to an audience like this, where we talk about teraflops of performance. But what cloud allows us to do is to make technology like a GPU chip available to every single person in this room to ultimately better support mission. Let me give you an example. When we take a high voltage power line, it's a very complex piece of construction. Maintaining a high voltage power line is incredibly difficult and incredibly dangerous. Today it's typically done by personnel in a helicopter or a fixed-wing aircraft who are then going and examining the health of the power line. They're looking at components like the isolators, like the colliery rings, and they're examining those components to see whether or not they're healthy. and whether that power line needs to be maintained. When we talk about the innovation that's going on with GPU and the power of cloud and having elastic CPU and infinite data storage, we can then change this scenario to make it more productive. So what you see here on the screen is an autonomous aircraft or a drone that is analyzing the different components of the power line. It's looking at, for example, the isolator ring, which is that component that's ceramic that's on top of a power line that ultimately holds the wire. It's using Microsoft Cognitive Services, and it's analyzing what a healthy isolator looks like. It's basically a set of rings that are stacked on top of each other. And it's then comparing that with existing or trained images of what a healthy ring looks like. It's then giving us a number, and you can see up here, those numbers in most cases are 99%. So it's able to, with a very high degree of confidence, tell us that this is in fact a healthy power line. Now what that GPU chip is doing is it's analyzing all of this imagery in real time. And then it's guiding the autonomous aircraft to the next part of the power line. So literally we've taken this highly dangerous, highly manual task, we've automated it, and now it's guiding an aircraft in an autonomous way along the power line, searching for the next elements that need maintenance. This would not be possible to do in an on-premise infrastructure. There simply isn't enough compute power. It's not possible to do on-premise except for the most advanced and sophisticated scientific groups to use a GPU chip on-premise. In cloud, this is something that you can easily do and write an application in a couple of hours or a couple of days. This is a real-life application, and it's working today. Now, of course, behind this, we recognize that all of you in defense, in government, have unique requirements. Security is critically important, and the threat level of security continues to change and elevate and evolve on an almost hourly basis. So we recognize that data residency is important, that personnel sovereignty is important. It matters, and you should have confidence in who is operating your cloud platform, who they're owned by, where they sit, that your data will reside in the United States. At Microsoft, we built a government cloud 3.5 years ago with 2 very large data centers, one in Virginia, another in Iowa. We've then been building out a dedicated network just for government around the United States, and we've been working with organizations ranging from large police forces to defense organizations, to federal civilian organizations, to intelligence organizations. And then we've been expanding this out even further. We've added another 2 data centers. And what we're doing here is we're literally bringing Microsoft's cloud to where the data resides. We're not asking you to bring your data to our cloud. We're bringing our cloud to your data. So as we look at government and where its key data centers around the United States resides, we now have dedicated dark fiber in proximity, and we have data centers also in proximity. And then we've been partnering really closely with defense to connect this infrastructure through the cloud access points, and we have production examples working today of using Microsoft's cloud through the DISA caps. This is just the beginning, and it's just the start for us. We're continuing to invest more. Another really important concept, and if I had to describe one of the key things that differentiates Microsoft from some of the other providers, is that we don't look at cloud as a binary state. Cloud should be something that you are using to ultimately be more productive, to do something better, or to achieve a better mission outcome. At Microsoft, we've delivered a technology called Azure Stack. And what Azure Stack means is that you can run the same code base that I run. You can use the same hardware that I deploy millions of times around the world, and you can put it in your own data center. Not just that, you can also put it literally on a submarine. in an aircraft, in a forward deployed, poorly connected scenario. And you can then use the same applications. You can write that application once, you can use it OCONUS forward deployed, or you can use it running in our hyperscale cloud anywhere in the world. And all of that same innovation that we're delivering to our cloud, we're making available on-premise with our Azure Stack appliance. And this can be as small as quarter of a rack or as large as multiple racks. So it literally can fit in the back of a truck. We also recognize that connectivity isn't perfect. And we've literally designed and tested this with the scenario of a submarine in mind. A submarine might go underwater for 6 months. It might be not connected at all. And then it will pop up, might be in port and have terrific connectivity. So Azure Stack is designed with those scenarios in mind that allow us to connect and poorly connect, use the same innovation, and really operate in any type of condition. So we're incredibly excited to be having this technology available for customers, especially as they're exploring a transition to cloud. Also overlaying this, and it's critical to talk about, is security and compliance. At Microsoft, we have invested billions of dollars, not just in cloud infrastructure, but also in security. 2 years ago, the discussion I used to have with customers was, is cloud secure? Now the discussion we have is, how much more secure is cloud than my on-premise infrastructure? When we talk to banks, when we share the most granular details of our auditing, when we share the details of our security posture, they're blown away. And supporting that, of course, is compliance. Microsoft Azure has the largest compliance portfolio on earth. We have 65 different compliance regimes that we support. And not just do we support them, but every single component of Microsoft Azure is compliant against those standards. When we look at government, we support everything from state and local government with a standard like CJIS that literally requires Microsoft to submit the fingerprints of the personnel who operate the service to the FBI, all the way through to FedRAMP and FedRAMP High, DISA Level 4 and Level 5, ITAR compliance for the suppliers that are building the equipment that you use, DFARS compliance, as well as standards like HIPAA and other standards that support tax data. So we've made a massive investment here, and we're really just the beginning. Literally every time we talk about compliance, we're growing and expanding, and we expect to continue to expand. Today we're talking about mission data, but Microsoft is fully committed to addressing classified data, both secret and top secret, as you look at moving all of your mission workloads to cloud over time. One of the examples that I love to share that's a great story of cloud is an application that the VA built. The VA sit on a large amount of very sensitive data. It's about people, and it's about people's health records. This data resides in their infrastructure, and it obviously has healthcare regimes that it must meet, such as HIPAA, as well as federal compliance needs, such as FedRAMP High. When we look at the VA, how they connect to the cloud and how they connect to the internet is extremely sensitive. So their ability of connecting to a cloud infrastructure in a secure way is a big problem that they need to solve. The next problem that they need to solve is they've got a lot of very important mission problems they need to solve. For example, how does a veteran get health care? Well, in this case, they went about solving the problem by building a cloud-first application that was able to take the healthcare needs of a veteran and then match that to the skills and speciality of a physician. What they're then able to also do is look at the location of that veteran as well as the location of that physician to show you on a map the hospitals with the shortest wait time. Now, what I've described sounds relatively simple, But when you drill into that data and you look at the sensitivity of it, you think about the connectivity of it, and then you also think about potentially how popular this could be, and all of a sudden you have a very sensitive scenario. And it's certainly fair to say that inside government there's been some attempts at building healthcare applications that have not gone as well, so there's also a political sensitivity. What we did with the VA is we were able to work with them to achieve a FedRAMP High ATO. And we did that using blueprint technology that we've created, which basically means that the security personnel focus on security versus paperwork. So we literally are able to accelerate that. We then connected their infrastructure to our data center directly using Microsoft Express Route. Then we built a cloud-first application. Now, on the first day of this application and when it was launched, it got close to 1 million unique users that went up to the website and tried to use it. Now, of course, the immediate concern you would have is of one of scale and one of security. The way the VA had set this up is they had set it to elastically grow in Azure. That initially provisioned it with 12 front ends, and then using a virtual machine scale set, they allowed it to grow elastically as load came into the platform. It could also then contract elastically as that load tapered off, for example, in the middle of the night. We also then set it up such that it can use all of the investments that I'm making in dark fiber, in capacity, such that if the worst thing happened, if a cyber attack happened, I can use my terabytes of network bandwidth such that that cyber attack never even comes close to the edge of the application. So when we look at VA, what happened? They got 1 million hits on their first day. Using those 12 virtual machines, at no one point did the CPU exceed 2%. So it never even needed to elastically grow. It meant that the VA only paid for what they used, and then they also had the confidence that the security of this platform would then work. So this is an application that's up and running and working at scale. What this is also an example of is what I call the second wave of cloud computing in government. For the last 2 years, we've talked a lot about lift and shift, about putting basic workloads in the cloud, and we've seen some great successes. We've been able to consolidate data centers. We've been able to shut down legacy workloads. We've been able to run them at lower cost. What the VA have done here is a good example of the second wave, which is they've taken a large data set. They've taken a sensitive compliance problem. They've worked through a connectivity situation. And then they've built a cloud-first application that ultimately transforms their mission in an incredible way. For veterans, this is an incredible win, and ultimately, for the VA, it's an incredible win as well and makes their infrastructure of hospitals, of physicians, and of course of technology way more efficient. It allows the VA to focus on healthcare as opposed to buying servers. Another really interesting technology that's going on in cloud, and we're seeing massive adoption, particularly across defense, is cognitive services. Now, the range of possibilities here is almost endless, be it something like a translation scenario. How do I translate what someone is saying in another language into a language that I speak? How do I recognize objects in a photo? How do I recognize a human being against a particular language set that I've trained? And at Microsoft, we've in fact been doing cognitive services for over a decade. It turns out when you build a search engine, you're building cognitive services. When we run our Skype platform and do billions of phone calls, we are doing real-time translation with Skype. We're doing image recognition. So cognitive services is a platform at Microsoft that we've been using at scale for over 10 years. And we've now brought it into our Azure platform. So if you take this particular image here, this is a train station. We then plug this in to our cognitive algorithm. And you'll see that it's recognizing some objects here in the image. It can tell us, for example, that there's 100% confidence that it's a train station. That there's a lower level of confidence that there's, for example, a platform. That there's a subway. Now, what's driving those particular confidence levels is a deep neural network. Again, previously talking about a deep neural network perhaps would have been unheard of, but you can think of it as a tree algorithm that goes down and down to continue to analyze it. Now, of course, the deeper in the tree we go, the more computing power we need, which is again where cloud can help because we have infinite amounts of computing power. Now, what we can also do here is we can allow an information worker, a mission worker, a soldier, an airman, to analyze these images and to make this neural network smarter. So, for example, we see here in this image that it's a subway with only 60% confidence. I can give my soldier an application that allows them to rate this 5 out of 5 stars. It is a subway. What that rating has then done is it's made my neural network smarter. It's literally building my artificial intelligence model so that next time this algorithm runs, it doesn't need to go as deep into the neural network. It's faster, and it has a higher degree of confidence. Now, I imagine all of you are a little bit like Microsoft, where hiring data scientists and training data scientists is incredibly difficult. Finding people with years of mathematics experience is incredibly difficult. But what this technology allows you to do is to literally have an average person start rating things with something as simple as a star model that's then making a deep neural network smarter and giving me artificial intelligence to go and analyze an image. And you can be doing this in a battlefield scenario, you can be doing it in an office setting, you can be doing it CONUS or OCONUS. Here's another example. This is my son, Charlie. Charlie likes ice cream. He likes food in general. And me, I'm an engineer. I used to be really hands-on keyboard, but now I do things like this. So I took this image over the weekend, and I went and I wrote an app in cognitive services. It took me 10 minutes, right? So I used to be technical is what I tell people. And cognitive services went and analyzed this image, came back and said, Charlie is 3, he's 3.5, so it's pretty good, and that he's male. Now, it also returned me back a JSON file, and in here you'll see some things. For example, it's told me with a degree of confidence that there's a window behind Charlie. And probably most of you didn't notice that. In fact, I'd forgotten. We were sitting here in the ice cream store. It can tell us that with 88% confidence he's eating, which I think is fair. I'm not sure he's actually touched the ice cream yet. And it's then giving me a whole set of other attributes here. So I can literally pinpoint the eyes on this image and the addressable points there. The key reason I mention this is obviously this is incredible technology that literally has limitless possibilities. I can, for example, train this particular algorithm just by uploading other pictures of Charlie. So when his face is turned to the left or the right, his hair is different. When he gets a little bit older, I can literally just upload images. But the reason I share this example is this didn't take 6 months. This didn't require a team of consultants wearing suits and carrying keyboards to come in. It was something that I could do in a couple of minutes. So our goal here is to ultimately make all of you as professionals more productive and able to use this incredible technology to ultimately transform your mission. Now, of course, inside defense, there is no question that security, that compliance, that connectivity are super important. The problems that you need to solve are unique. At the same time, it's critical that we're bringing that same commercial innovation that a bank that's too big to fail or a retail organization that's transforming is using. That same innovation should be available to all of you at the same pace. When we look at our Azure platform, we do somewhere between 150 to 1,000 different software releases a day. We are literally changing the platform every several seconds, and we're making it smarter, we're making it more secure, more reliable, we're bringing innovation. And our commitment is that that same innovation, that same pace of innovation is available to all of you as you look at defense workloads. Earlier this year, we released at Microsoft a dedicated set of Azure regions that are hyperscale regions with all of the innovation that I described, dedicated just to level 5 workloads. This is the same platform upon which our communication and collaboration technology of Office 365 builds. It's connected to the CAP, and the only people that use this region, the only people that can get into this region are defense customers with a level 5 requirement. This is a great example of where Microsoft is investing massive amounts of money as we look at organizations inside defense moving to cloud. And again, this is simply the beginning for us. This is a level 5 region. We recognize that you have massive amounts of classified data, that you're working with, for example, partners across the world in coalitions, that your needs today may be different from your needs tomorrow. A great example that I like to describe with our DoD regions was an element of the Defense Department in the United States that was collaborating with a partner in the Five Eyes. That collaboration was time-bound. It was a mission scenario that lasted 2 months. Now, in the past, the way they would have dealt with that is they'd go and buy servers and dedicated equipment, they'd provision it, and it would in fact take some time to set up and then decommission. What this particular organization was able to do was to provision a virtual data center. So using a set of scripts and code, they were able to, in less than 1 hour, provision an entire data center, the virtual machines, the storage, the virtual networks, the security policies around those virtual networks, such that they had an entire isolated data center running on this infrastructure, and then they controlled the permissions of who could access it. So they were able to, for example, share it with this Five Eye partner, and then they were able to collaborate and exchange information. And when they were done, they shut it down. So you start thinking about some of the possibilities here. They really do start to enable scenarios that were not possible, that required, for example, exchanging information in very inefficient ways. Now, in closing, I wanted to leave you with a couple of different commitments. Really, the first one is a super important one, which is I'm not standing here today promising you that I have a perfect solution that meets all of your needs. In fact, I'm excited that I don't. So let me explain that. We ultimately look at how do we build a better cloud computing platform. It's through a partnership and a dialogue with each and every one of you. Why do we spend hundreds of millions and billions of dollars building infrastructure for people like you? It's because we ultimately believe the innovation that you can help us create through partnering together can make our entire cloud platform more secure, more robust, and more scalable. Meeting, for example, a DISA Level 5 requirement brings benefits to my financial services customers, just as working with a financial services customer and solving a compliance problem can bring innovation to defense. So we want to be fueling that commitment. And it's worth noting that this commitment isn't just around traditional Microsoft workloads. In fact, when we look at our workloads today, between 30 and 40% of the load that we run on our platform is Linux. It's open source. It's container technologies like Kubernetes. And we're not happy with that. We want to be running more. We have more people that sit in my building in Redmond and Washington writing Linux code than writing Windows code. And what that's about is ultimately a partnership. It's about a dialogue with customers and meeting them where they need. We run 10 database technologies on top of Azure. 9 of them are not Microsoft. 1 is SQL Server. We run SAP at scale, and in fact, I would argue we run more SAP than SAP. So just what's going on here is super incredible, and it's ultimately through a partnership and a dialogue and mutual learning together. As I mentioned, our commitment is bringing innovation. I only ask that you use our cloud platform when it helps you be more innovative and do something better than you can do it today. And that pace of innovation, the bringing of literally hundreds of releases a day of new functionality, of security enhancements, of reliability improvements, that has to be coming to defense with the same security and the same reliability that I'm providing to a Wall Street bank. So that commitment of bringing commercial innovation is absolutely crucial, especially as we look at a global world in which our adversaries have that same commercial technology available to them. Hyperscale is super important. I'm investing billions of dollars so that you don't have to. And I'm doing it in a way that meets your security and compliance needs. I'm elastically doing it on every country on earth. Why aren't I spending more? Because there's nothing more to buy. We're literally consuming the entire world's supply chain of everything from generators to solid-state hard drives to fiber cables. And we're doing that because that's where the world is going and that's where we believe the future of our business is. And we're also doing that in a way that allows you to benefit from our economics. So as we continue to invest, you're using what you pay for, and then you're paying what you use. And then finally, we're committed to working through the most complex security and compliance problems. The best dialogues that I have in government are ones where people bring in their most difficult people, the people with the most serious security concerns, and they walk through and we address these concerns. It might take days, it might take weeks, but together, the worst possible scenario for me is I've made my platform more secure. The customer has learned in conjunction with us, and we're able to build a partnership where we share the right information and provide the right level of detail so that everyone feels comfortable. For example, I've given my financial services organizations the ability to come and audit my data center. They can literally show up with their auditors and look at my physical data center. So for people that want to understand the physical infrastructure, we've been able to find a way to do that. When we look at, for example, everything from how often do we patch to how many servers do we have to have we addressed a vulnerability, we're providing that data as part of a continuous monitoring regime. So the bottom line is, as we think about assurance and we think about compliance in conjunction with the attributes of the partnership I described, we can ultimately find a way to work together and resolve some of those concerns. So with that, I want to thank you again for hosting Microsoft here in Alabama. As I mentioned, we've been coming here for over 20 years. We're very excited about the investments that we're making in cloud and ultimately helping all of you transform your mission. So thank you very much.
Ladies and gentlemen, we have time for one question. Captain Granger, could you ask that one question?
What, in your view, is the biggest hurdle to DoD adoption of Azure and cloud technology?
So that's a really great question. And let me talk about what's gone on at Microsoft. At Microsoft, we're a large organization with over 100,000 people. And we've been making a pivot to cloud for between 5 and 10 years. And at the root of that, everything changes. Culture changes. People's jobs change. For example, at Microsoft, we used to build software once a week or once a month. We now build multiple times a day. So that life of an engineer and how that engineer works has changed. When we talk about how do we sell cloud, it's different. Literally, you no longer talk about going and buying a big chunk of cloud. You buy what you pay for. It's consumption-based. When we talk about support, the proximity between me as an engineer and you as an end user is much, much closer. So I guess the answer to your question, I believe, is culture. It's recognizing that this is a different way of working. And at the same time, it's also a very exciting way of working. What makes me so passionate about Azure is the discussion that I have with any one of you in the room is not about bits and bytes or numbers of virtual machines or the amount of storage. It's ultimately about a mission outcome that you want to change. Now, culturally, that's a big change. We're not talking about how many users you have and how many licenses of Windows or Office you want to buy. They're important, but it's absolutely about how do we transform this mission. And so culturally, that's a very different discussion, and one where we've got to make sure that everyone feels comfortable in all of their different roles and can embrace that cultural transition. Do we have time for one more?
Sure, we could take one more. Try to squeeze you in.
What
Go
is the
ahead,
timeline for having Microsoft Azure available on Secret and JWIC's networks?
A roadmap question to 2,500 people. The answer is we are fully committed to addressing the full spectrum of government data. We absolutely are. We've not shared publicly any roadmaps, but we recognize the need to do that and to do that soon. Practically, what we see occurring is people making technology platform choices now that last a long time. So as you look at how do you go and train people inside your organization, what technology do you pick? How do you think about solving a security problem? You're making choices now that have very long-term impacts. So part of why we're moving so quickly and we're investing so much so quickly is because we want to be influencing those choices. So the bottom line is we recognize the urgency and we want to move really quickly.
Thank you, Mr. Keane.
Thank you.